Hello, guys. Last talk of the night. Thanks for being here. My name is Kevin. I'm one of the co-hosts for the Meetup here in Seattle. And yeah, I'm here to talk about Iceberg and Delta, collaborating across the table formats. First of all, I just want to thank everyone for being here on a random Thursday. Great turnout, as always. And thank you to all the people who are sponsoring and helping with the Meetup. Thanks to Microsoft for getting the space and the food and everything. Really awesome to have the space here. Yeah, this is my talk. Let's go. There's a live demo too. I'm going to speed up this because we're getting kicked out at 7:30. So everything will be available online afterwards. The talks, the recordings, the code. So you can check it out afterwards. Okay, a little bit about me. I'm an Iceberg committer, open source contributor. Used to work at Stripe on data platforms, especially with Iceberg. I grew up in New York. I went to Northeastern in Boston, and I'm here in Seattle now. What we're going to talk about, a little bit about Iceberg. Probably already know. The previous talks I have explained all really good for both Iceberg and Delta. We're going to talk about some of the similarities. Going to have some takeaways from the talk, a live demo, and a Q&A. And just a disclaimer, I don't know that much about Delta. This is like everything I learned in like a few days' time. So, you know, if there's something that I misspoke, let me know. Cool. So, you know, you're already seen this like a million times. Like no Iceberg talk is a real talk without this diagram. You got the catalog, the metadata, the data, right? And then snapshot, manifest list, manifest file. I think the biggest thing to note from this is that there's a clear separation between data files and metadata. So the whole point is that you have some metadata about your data, which then you can, you know, it's an abstraction layer that you can work through, right? And the reason why this architecture came to be is, you know, if you have a lot of data, right, like petabytes of data, and you need a way to efficiently go look up, sort, do anything with it, you kind of need some extra data about your data, which is the metadata part. And then for Iceberg, of course, there's this whole catalog layer that you just heard about. Great. Delta, kind of the same thing, which is the theme of this talk, actually. So for Delta, you have a directory path, which is either like, you know, on object store or on your local disk. You can think of it as a folder. It's a directory structure. Inside, there's a Delta log folder, subfolder, where it hosts all of the metadata. They're called Delta log files. And there's checkpoints, that's extra information. And then there's your data file, right? So the whole point is still, you have a lot of data. You need some data about your data. That's the metadata. And then the access is through, you know, whatever represents your entire data set. For Iceberg, it was the catalog, right? I say, here's my catalog. My catalog knows what this table is. Technically, there's a metadata JSON that points to the state of the table. That's what like you get all of the data from. Here, same thing. You say, this is where my table is. It looks into the Delta log. It reads all the metadata and said, these are all my files. Very simple. And yeah, thanks. I was trying to find an equivalent diagram. Couldn't find one until I found Danny's blog from 2023. So thank you to Danny. Okay, so similarities. Already talked about table layout, metadata, data, right? That's kind of the whole point here is that you have a lot of data. You have some metadata about your data. We're going to talk about engine supports. We're going to talk about read path, write path, like generally what you do with the table and with the data. And then we're going to talk about the metadata themselves that makes up all of the magic that we talk about. Okay, great. So, you know, Spark is the thing that comes up. It's like the primary way to interact with this, right? And for table formats, what that means is you just read it and write, and you say, read Iceberg, write Iceberg, read Delta, write Delta, and you just give in the beginning of the file or like what represents as a table. Very simple. And the story is, it's the same thing for Trino, all the engines that you see, right? There's a concept of a table, whatever that means, for your engine, and then you either read to it or you write to it. That's the thing. It's all the same. Okay, let's look at the read path, right? As I alluded, if I have a Delta table, what I do is I give it the root directory, right? The root directory says, this is where my table is, right? In S3, it says, you can come up with your own structure, right? It's like S3 warehouse namespace table. Everything under the table has both my metadata and my data, right? Iceberg, a little bit different. There's one more layer of indirection, which is the catalog. Catalog tells you, instead of like providing a subfolder that says like, here's my data and metadata as a table, it says, here's a key value lookup. You say, my table foo bar is right here, and here's the metadata JSON, and then the engine goes and just like fetches everything else, gets the data, gets the metadata, read, write, both doing it. And then the kind of interesting part is that while looking into both of the projects, there's a lot of similarities. One thing is, Iceberg has this concept of like file system tables, or like the Hadoop catalog is what people call it, which is like just a catalog, quote unquote, right? Because usually you think of catalog, it's like the Hive Metastore, Polaris. Like these are things that runs with active runtime as a service. But Iceberg has this concept of Hadoop catalog, which is my catalog is on disk, right? I just go, I provide a path to it. It goes, it says, I'm going to look up your metadata JSON. There's a couple ways to do that. And it's part of the spec, not really recommended, but it is there, right? The concept is still there. I give it where my folder is, and it reads all the files, the data and metadata in there. What's interesting is that a lot of the end users, because they don't want to deal with the catalogs and having a runtime, comes up with like clever tricks. So in DuckDB right now, the extension for DuckDB and Iceberg actually has a metadata guessing functionality. And if you are in the Iceberg community, it's kind of frowned upon to do this because XYZ, a lot of reasons. But if you're an end user, it just works, right? Like I say my table is in bucket this, DuckDB read that, and it just works. So for some people, it just works. And then, Iceberg also has absolute path as of right now. So like everything is absolute path addressable, which means if I'm on S3, the bucket name and the metadata and the data file is all encoded in the metadata itself. And the metadata is supposed to be immutable, right? Like you're not supposed to go change it. It's supposed to be like only one version, you write it and you never touch it. Which is kind of a problem, right? Because if I want to move from bucket A to bucket B, all my metadata is now wrong. Or if I want to move from like cloud A to cloud B, everything's messed up because, it's like they have different protocol names, like S3 versus like GCS or something like that. But in the Iceberg community, there's this concept of like relative path. Let's support relative path inside the spec itself. It's still, there's a proposal of, I haven't checked yet, I think it's active, but the idea is Delta's already doing this, right? There's something that the Iceberg community wants, and they're all kind of going the same direction. And then, through the read, Delta itself also has a catalog, Unity catalog. I can go to Unity, connect to Unity, it's a runtime, and say, hey, give me a table, foobar, and it gives you the table, which gives you the directory, and then you just read it. So yeah, there's a lot of similarities, a lot that the projects are converging. Okay, what about writes? Okay, both projects use MVCC, which is multi-version concurrency control. I double checked that on the Delta side. I know Iceberg does for sure. I double checked that on the Delta side just to make sure I'm not misrepresenting it.
It's version 1, Delta, version 2.
Okay, there is some caveat. I think something about version 1 and 2.
Version 1 is not catalog aware.
Okay, version 1 of Delta is not catalog aware. Okay, OpenAI didn't know that. Claude also didn't know that. But okay, I double checked. But yeah, the whole thing is, Delta, when I write my data file to like object store, and then I say, okay, now I want to commit all my data to the table itself, which means I have to write my metadata. which is transaction log, right? So I can append to the transaction log in a append-only manner. I say, here's my updated table state, right? I added some files, I removed some files, and probably a lot of other operations that you can do. But the whole point is, when you have multiple writers, the first one wins, or the fastest one wins, right? And then everyone else has to retry. And Iceberg has the same similar functionality. This is done through the catalog layer itself. The Iceberg catalog, all the different limitations, the Iceberg REST catalog protocol, they all support this concept of like MVCC and the first writer wins, right? What's interesting is that, you know, the Delta project has this, or is creating this concept of coordinated commits, which is in Delta Lake 4.0, which looks like a catalog and a commit protocol that says, sorry?
Version 2. We're moving to version 2.
Version 2 of
MVC.
MVC?
Yeah, the Delta is going to adopt version 2 of MVC, so it'll be catalog aware.
Yes.
Yes.
So that's the whole point, is that
Yes.
Delta is becoming catalog aware, just like Iceberg, right? There's this idea of not only do I commit to my object store, my metadata, I'm letting another service know that something has changed, right? Same thing, Iceberg's been doing this with the catalogs, with the Iceberg REST catalog spec. And then, you know, what I talked about with the file system table, technically, I can update my Iceberg table just with the object store and not with any catalog. Not recommended. There's a lot of reasons why. You can read about it on the internet, but it's possible. If I have a single writer, and I know I have a single writer, and I know only one process is doing it, then yeah, I can just commit to the cloud and read from the cloud and everything works. Okay, so metadata. What are these metadatas? Okay, they track data files. There's some delete files too. There's like data files too. They track the table state. So, you know, I have some data around in my cloud bucket. I need to know what the schemas are, what the partitioning is, what the properties are. So these are all kind of a layer of abstraction above my data itself, right? This is where the table formats, the level of abstraction allows these formats to provide extra functionality, right? I can provide a schema that says everything under this table is schema aware and is compatible with the schema. I can provide a partition that says, you know, my 3 terabytes of file is partitioned in this way so that if I'm looking at, you know, a single day or a single partition, I can skip like 99% of it, right? So these are all reasons why like table formats are a lot better than just regular files. And then, you know, you have history, right? How many times I commit. There's branching functionalities, at least in Iceberg, you know, in Delta. You can have like additional stats, right? Things that helps you prune that read a lot more. I can say that, you know, my table is sorted. My table, I can add a Bloom filter in the table or a column. I can add an index to it. So it's just different ways of adding more and more metadata about your data. And this is all done through the table format layer, right? And this is the same thing for both Iceberg and Delta. Okay, so very fast, takeaway. Like I said, table formats, just metadata over data. Very simple. You know, there's a lot of diagrams, but it's just metadata over data. Depending, like the design principles and the design decisions are for different projects are all based off of, you know, different ways to represent that, right? Like Delta has Delta log, JSON files. Iceberg has snapshot, manifest list, manifest files, and like JSON, Avro, all the different stuff. But at the end of the day, to an end user or to, you know, people who work on this too, it's just metadata over data. And yeah, to end user, you know, you look at Spark, it says, here's my table, read the table, write the table. Like as long as I get like an entry into the table, it just works, right? So all of this stuff is abstracted away. Yeah, there's some difference in design decisions that just because you know, people come from different like contexts and scenarios. And I guess this is more of an opinion than a takeaway, but I think unification is inevitable, but in different layers. Part of the theme of this meetup was interoperability. You see it with Xtable, with translating between different table formats. You see it with Polaris, with, how do we make sure the catalogs all talk to each other? And then, there's Delta Uniform, universal format, which just says Delta Lake, Iceberg Hootie all consist of Parquet files and a metadata layer. And I think during the press conference for Uniform, the kind of slogan was that, metadata is a very, very, very small percentage of your actual data, right? So if I have petabytes of data, my metadata is a fraction of that, like a 1% of that, hopefully, if you keep it right. Right, so it's a lot easier to work with metadata about your data files than with the actual data itself, because that level of abstraction gives you extra information to do the things that you want to do. Okay, so I hope we're still good on time. I have a live demo. So one of the issues with Iceberg table, or not an issue, but something that comes up a lot is, how do I compact my Iceberg table, right? And the traditional way is you spin up a Spark engine. Spark has procedures for data file compaction, and we're going to do something different. We're going to use the Delta library to compact Iceberg tables. Kind of cool. Okay, first of all, what is compaction? Someone? No one? Okay, so I have some data files. I have a lot of data files, right? And they're in different shapes or forms. I want it to be in a form that I would like. So a very common problem is I have a lot of small files, right? I have 1,000,000 1 MB files, right? For Spark, what that means is I have to read 1,000,000 files, right? I have to open one file, or, I can parallelize, but I still have to open 1,000,000 files, or I can just open 1,000,000 megabyte file, whatever that is, right? But the recommended is, 512 megabytes. So what I want to do is I have a lot of small files. I want it to be neatly packed into 512 megabytes so that engines can read it optimally. So that's the compaction problem, at least one part of the compaction problem. Let's get to the live demo. Hopefully this works. And yeah, so this Jupyter notebook is on Gist, so you can run it yourself if you want. We're using Python, so the only dependency is the Iceberg library and the Delta Lake library. And we're releasing 0.9.0. I'm using the RC3 as a way to show it, but try it out yourself. Okay, so some notes here. We're compacting Iceberg table with Delta RS. I'll get to Delta RS later. There's a lot of interesting things that they're doing in that library too. We're going to generate some Parquet files in this as a way to demonstrate just random files. I wanted to generate TPCH, but there's some weird things going on with that. So I ended up just generating random strings or numbers. We're going to create an Iceberg table from those Parquet files. And then we're going to create a Delta table from the same Parquet files. And then the Delta library itself has a compaction function, which just takes some files and gives you back some files that's neatly compacted. And then we're going to replace it in Iceberg. So the point is, if you have an Iceberg table, from an end user perspective, add a table with 10 files, and then I call this compact function. Now my table state is actually just 2 files. The 2 of the same data, but 2 files that's neatly compacted. Okay, let's do this. So I'm going to install a bunch of stuff. This is all on Jupyter, by the way. It's running locally. You're going to import a bunch of stuff too. So one of the neat tricks for the Iceberg library and also the Delta library is that it doesn't necessarily have to work on object store, which is super cool because one, it works locally on my machine. It's just a local file system. 2, I don't need to spin up a Docker container, which, it's not difficult, but it's still more infrastructure to spin up. But this is essentially there's a local directory called warehouse, and I'm gonna remove everything there, recreate it, and then see that there's nothing in there. Okay. And what I'm gonna do is this actually used DuckDB. It generates Parquet files in ZSCD compression. I set some random, like, not random, but I set the row group size and row group per file to these specific amounts because I want to get 10 files with 100K records each. So essentially what this is doing, it's generating a number from 1 to 100 to 1 million. And then I'm going to partition those into 10 files using DuckDB, which is a great tool. So we're going to do that live, and it's very fast. And then I'm going to get those tables. Okay, so this is actually in my machine. I removed everything before. We just generated 10 Parquet files. I'm gonna run the tree, so you know I'm not lying. There's 10 Parquet files over there. Okay, great. So imagine this as your S3 bucket, whatever object store you use, but right now it's just my local machine, right? What I'm gonna do is I'm going to go into Iceberg land, create a catalog or connect to a catalog, create an Iceberg table, and then add those files to my Iceberg table, so then I can use them. I can use them and read them, right? And to do that, I'm using the Iceberg library. So, this just adds all 10 files. And to keep me honest, I'm gonna do a scan and a count just to make sure that we have 1 million records. So what this is doing is we have the catalog, you load the table as an Iceberg table, and then I do a scan and a count. And then I can do an inspect, and it tells me all the files that's in my Iceberg table. So this directly goes through all of your metadata, Iceberg metadata, and say, give me all of the data files that you're tracking. And it's right here. And the interesting thing is, you saw a lot in the diagram, but this is the structure of the directory that's on your object store, right? The same thing as you saw before. This is my base bucket. Here are my data files. This is my metadata, right? It has the metadata JSON, which is, if you go back to the diagram, the top part. It has your manifest list. It has your manifest file, and these are all tracking the data files. So I just recreated a whole like Iceberg table on my local machine. And this is the fun part. Okay, we're gonna take what we have, and we're gonna create a Delta table out of it. You kind of already seen that with Xtable, right? What does it mean to create a Delta table out of it? Well, it just creates a Delta log for you, right? I still have my data files. I have an extra metadata, Delta metadata, that's a Delta log file. And we're gonna actually take a look at what's in there. Okay, there's a lot of stuff in here, but the interesting part is, see these statements? This is saying, I've added this file, right? And there are 10 of these. So this is what the metadata is tracking. It's tracking what data files do I have, right? This is saying, as part of my Delta table, I've added 10 data files, right? It's all in here in the JSON. Great. And then I can use a Delta library. I can load it up as a Delta table, read it as a Delta table, and also find out what the data files it's tracking, right? So, 1 million records tracking, these are, I should sort them, but this is 10 files that we created. And then the interesting part is, because that was the read operation, nothing's really changed, right? Like my warehouse is still the same warehouse. Okay, so fun part. Now that I loaded up as a Delta table, Delta, the library itself, comes with a compaction function. So what it does is, once you have a Delta table, you can call optimize, you can call compact, and then you give it a target size, right? So as I said, we want one or multiple 512 MB files, and these are like optimally sized, right? So what I can do is, now that I have it as a Delta table, that was pretty fast. I mean, it wasn't that many files, but this is using Rust under the hood, super fast. even on my local laptop. I tried it with TPCH data, lightning fast. And look what it gives us, right? It says, here are some files that are added. Here's some files that are deleted. Gives you some stats. Great, right? I can go back to my Delta table because presumably, Delta is state change, right? I just compacted the files. It went from, 10 files to probably one. Yeah, just one file, right? So still the same number of records. And, we can go further and say that they're the same actual data records, but I didn't want to do that. It should be the same data. And now Delta, instead of tracking all those 10 files, is tracking this one big file that is just compacted. And, we can list directory again. Great. So what happened here and how is it different? Delta has a zero.json. So it's a new state. It's a new metadata state, right? And Delta also wrote this new data file that it's now tracking. And we can look at the new metadata that Delta has, right? It says, okay, we removed some of your files, right? All 10 of your files. And then there's an add operation somewhere in there. So we added this one file. That's what Delta's saying, right? And then I go back to Iceberg land. Iceberg, because it has its own set of metadata that's tracking the data files, hasn't changed at all, right? It's still tracking the old 10 data files. Okay, so what I want to do is, I know the result of my compaction. I just need to shimmy it in and make sure that my Iceberg table now only tracks that one data file, right? So what I do here, and it's a little bit of a hack because it's really supposed to be like a replace operation in Iceberg, but I'm going to do delete and add as like two separate operations, but it's in the same transaction. So it should all fail or it should all pass, right? Okay, great. And then I'm going to count the Iceberg table again. Still a million files, a million records. And now Iceberg is tracking the new file, right? So what I did is I just replaced whatever Iceberg is tracking to the new data file. And that's compaction, because from Iceberg's perspective, we switch from 10 data files to one resulting data file, and it's compacted. And yeah, and Iceberg created some more metadata to track the new state, blah, blah, blah. But yeah, that's all it is to compaction. So, if we really want to implement this in the Iceberg library, we'll do we'll add like a compact function, right? We probably don't want to pull in Delta Lake library as part of like Iceberg's official library, but because Delta is written in Rust, we can pull out some of the dependencies and expose them in Python. But yeah, this is compaction. And I added some resources to the bottom. That's the demo. Hey, okay, what time is it? Okay, we're still good on time, I hope. Okay, so I was hoping someone's gonna ask about deletes. Because Iceberg doesn't only have data file, it has delete files as well, which tracks like records that are deleted within the Iceberg table. Right, what do we do with that? Because it's represented differently in Delta. How do you like make sure that they're like when I'm compacting, I'm just not like dropping records, right? Where I'm like, it's not the same amount of records. The good thing is, Delta has this concept of deletion vectors, and that's coming in Iceberg v3. So, it's this whole convergence story of, things that are good happening in one table format is coming to another table format. So, when we're in v3, if you have deletion, you can convert everything to DBs. Delta itself will understand the DBs. Compaction will work without any manual configuration or manual intervention, and everything works. Okay, so just a little slide about the future. I think everything is going to build on like reusable components, because at the end of the day, the things that the functionality that you're doing will be the same no matter which table format you want. Like maybe some of the like the design decisions and some of the like optimizations are different, but everyone is going to go to a cloud and get some files, right? There's this Apache project called Apache OpenDAO, which is open data access layer, right? It just says, I'll figure out all the ways to reach out to a file system. You don't have to worry about it. It works for everything, right? And then yeah, open lakehouse. So I think, there's going to be more and more universal components that works across every table format, maybe even the catalogs. And the whole idea is, maybe we can build everything in Rust, lakehouse RS. Someone else came up with that term. Danny came up with that term. And the whole idea is, if we were to write everything in Rust, all the functionalities, all the features in Rust, and expose them as, bindings in either Python or other languages, then everyone wins, right? But the compaction functionality is written in Delta RS. It's a Rust binding that it's exposed to Python. I can pull that into the Iceberg Rust library, expose the Iceberg Rust library to Iceberg Python. It's the same function. I'm just moving it around. And some references. That's it. Thank you for your time.